This video will explore our top 5 important concepts pertaining to estimating parameters, so things like confidence intervals and finding minimum sample sizes. Let's take a look. Listed below are amounts of arsenic in micrograms per serving in samples of brown rice from California, and this is based on data from the FDA. Use a 90% confidence level to construct this interval. So the first example we do together, we're going to look at by hand and then follow up with how to go about these in the calculator. Think of this almost as step 0. Don't forget you have to first find your mean, standard deviation, etc., all for this sample. So to do this, we're going to go in and use our 1var stat in the calculator. So stat edit, just enter the data into list 1. Be sure to pay close attention as you're entering this information. You want to make sure that you have everything correct. Even if something is slightly off, it will completely change your answer. And you may even want to go back through and just double check all of your numbers. Make sure that you have no errors. It might take a moment, but this will save you time in the long run from making a mistake. Okay. Then we're going to go back to our main screen and use 1var stats to find the mean and standard deviation. So from this we find that we have a mean of 6.45. Our sample standard deviation is 2.455. Remember, always err on the side of more decimal places. You can always round your answer at the end, but you cannot undo a mistake because you rounded too soon. We have 10 total values, which we could have counted up from here as well, which means we will have 9 degrees of freedom. Remember, that's n minus 1. Now, being that we're constructing a confidence interval and we have our population standard deviation unknown, we have to find our t-statistic. This can be found using the table, or you can also use, if you have a TI-84 or higher, the calculator to go about finding that. And to do so, you would use your inverse t function, which is found under the distribution menu right here, and that's option number 4. When they say area, that is the area to the left, being that this is a confidence interval. Remember that it is symmetric, so 90% means 10% total between the tails. Half in each tail is 0.05. Remember, that means it is centered 90%. Tell it how many degrees of freedom we have. And using that inverse t function, we can acquire our t value for using in our function, or equation rather. Now, to go about finding the margin of error, that is equal to your t-score, which is 1.833. Because you're going to be adding and subtracting, and how this is symmetric, the negative does not matter here, times your standard deviation, divided by the square root of your sample size. You're going to go ahead and enter this in the calculator. So here we have 1.833 times 2.455 divided by the square root of 10. That means that our margin of error is 1.423 approximately. You can worry about rounding at the end. And then to get our confidence interval, that is x bar, 6.45, plus or minus that value. So we have 6.45 plus or minus 1.423. You're going to subtract to get the left, add to get the right. When we subtract, you get an answer or result of 5.03. Remember, this is in micrograms according to the original question, so we're going to make sure we include our unit. And when you add, we get 7.87 micrograms. So piecing that all together as our confidence interval, it's between 5.03 micrograms, which is less than our mean, which is less than 7.87 micrograms. Our next question here is going to ask us to essentially interpret our results for this problem. Can the confidence interval be used to describe the arsenic levels in Arkansas? So if you think about this for a moment, the data came from brown rice found in California. It would not be appropriate for us to use Arkansas or to use California to compare to Arkansas because you are looking at two separate locations. If all of your data comes from California, you could inadvertently cause a bias by trying to use that data to describe what might be happening in Arkansas. So for those reasons, no, this would not be appropriate. If instead you wanted information about Arkansas, you would definitely have to take a sample from that, the brown rice that's being produced in Arkansas. Instead, again, you cannot compare one state to another and expect them to be unbiased in result. For our next example, let's take a look at how we can use the calculator to construct a confidence interval, similar to what we just did, only instead of by hand. Again, all in the calculator this time. So first thing we need to do is use one of our stats to enter our data, and I'm going to do this off camera to save a moment of time. Now that we've gone in and entered our set of data into our list, we're going to go back to our main screen, and in the stat menu over under tests, you're going to find the t-interval function. You have to scroll down a bit for this one. So this option right here is number 8. We have our data in list 1, so we're going to highlight data, tell it our data is in list 1. Frequency, leave that as 1. It's a placeholder in this case. We do not have a frequency distribution. And verify the confidence level. So here we're looking at the amount of time it takes for students to complete their bachelor's degrees. At a 95% confidence level, let's estimate the time it requires. So using a confidence interval to do this. Now from the t-interval function, you'll see that it's already given us our lower and upper bounds. This is a little bit different than when you take the time to do this by hand, because unlike doing these by hand, it jumps you straight to the answer. Now, it's still up to you to interpret how this all ties in, amongst other things. If you did want your margin of error, although it's not given to us, you can still find your margin of error. Remember that the margin of error is double the distance from your lower bound to your upper bound, because you find it by adding and subtracting from the mean, and the mean should be dead center here. So if you did want to find your margin of error, find the middle point between these two things, you can do that by taking the mean. So again, if you want the margin of error, it's not something you have to do, but if you were looking for it, you might be asked to find it, and you should still know how to do that even if you're using the calculator. Split those in half. That's your halfway point, which you'll see is the mean. And what's the distance between the mean and either of these bounds? You can subtract from either. And you'll see that this here is your margin of error. Bear in mind, it's not the only way to go about finding it. There's other approaches you can take, but this is one of those techniques. So what we found down here, keep in mind that this is your margin of error if you were in fact looking for it. Okay? So the follow-up question says, does it appear that college students typically earn a bachelor's degree in 4 years? Well, what could we say to answer that? 4 years does not actually fit within our lower and upper bounds. So although 4 is not within the confidence interval, that might indicate we have to look a little bit more closely at our data. You'll see here that over half of our data points is between 4 and 4.5. So how would it be that most students might be finishing in 4 years? Well, if most of our data is from 4 to 4.5 and then the rest of it is scattered from 6 to 15, you'll see very quickly, and you don't have to graph this to recognize, that that data is nowhere close to approximately normal. If your data is nowhere close to approximately normal, perhaps this confidence interval is not indicative of what's happening in the masses. So do college students typically earn a bachelor's degree in 4 years? Well, according to this information, most of them do actually finish, right? That's over half. They finish between 4 and 4.5 years. So perhaps this confidence interval is not appropriate, or not necessarily appropriate, but perhaps the confidence interval is not the best fit for describing what most college students are in fact doing. For our next example, let's take a look at finding a confidence interval for proportion-based information. Similar concept, we can also use the calculator for this. However, you're looking at percent-based things as opposed, and remember those percent-based things are based off of generally qualitative information, right? Are people having this adverse reaction or not? Versus quantitative data like we saw with the time it takes, very different information. The drug Eliquis is used to prevent blood clots in certain patients. In clinical trials, amongst 5,924 patients treated, 153 developed an adverse reaction of nausea. Construct a 99% confidence interval to estimate the proportion of patients who experienced nausea. So to go about this, first let's make a list of all the information we know. We know we have a sample size of 5,924 patients, and 153 of them did in fact have that adverse reaction. So that means that our sample proportion is 153 over 5924. Now, this part's not necessary for plugging into the calculator, but it could be useful just for our own comprehension and understanding. So take a moment and find out approximately what that would be. And the calculator will give you this information as well if you follow through in that way. So it's about 2.6% roughly of patients develop nausea as an adverse effect. Now, to find our confidence interval for this, similar to where you found the t-interval function under your tests, if you scroll down, you will find the proportion interval. And in this case, we have one proportion, so we're looking for a one proportion z interval. Going to go ahead and plug in our information. X is 153, N is 5924, and we want a 99% confidence level, so 0.99. What this produces for us is a confidence interval that spans from about 2.1% to approximately 3.1%. So what can we say about this? We can be 99% confident that the true proportion, so we're talking about the population proportion now, not just these patients who did the clinical trial, of patients who will be affected by nausea is somewhere between 2.1% and 3.1%. So now this is, again, what we're estimating will happen to anyone who does in fact take this drug. Our last example that we're going to take a look at here is pertaining to finding minimum sample sizes. The Wechsler IQ test is designed so that the mean is 100 with a standard deviation of 15 for the population of normal adults. Attorneys are a group with IQ scores that vary less than the IQ scores of the general population. Find the sample size needed to estimate the mean IQ of attorneys, given that we want 98% confidence that the sample mean is within 3 IQ points of the population mean. So of all of this information that they share with us, let's make a list here. They told us that the mean is 100 with a standard deviation of 15 points. We want to be 98% confident, so our confidence level is 0.98. And we need to estimate this within 3 IQ points. That means that we need our margin of error to be within 3 points. So our margin of error is 3. To construct a minimum sample size, we also have to find the z-score that would be associated with 98% confidence. So again, think about what the picture looks like here. That means if this is 98% in the middle, 2% left, so 1% in each tail. And to get this number, you can either use the table, your z-table specifically, or the inverse norm function in the calculator. The area to the left is 0.01, And when you're looking for a z-score, you use placeholder values of 0 and 1 for your mean and standard deviation. Remember, that's because the mean and standard deviation of your standard normal distribution fit those criteria. So from this, we find that our z-score in this case is 2.33. So with a z-score of 2.33 and the rest of this information, we can plug in to find our minimum sample size. Our minimum sample size is given by the z-score times our standard deviation divided by that margin of error that we need to stay within, all of that squared. So we have 2.33 times 15 divided by 3, and all of that has to be squared. So this gives us 135.7225. Keep in mind, however, that this is a minimum sample size. So regardless of what this number ends up being, if there is any decimal at all, if it does not come out to be a whole number, you must always round that up. If you round this down for whatever reason, you would be underestimating. So we always have to round this up. So how many must be surveyed here? We need to survey 136 to guarantee 98% confidence within 3 IQ points. Thank you for watching.